Okay. Okay. As you know, utility is one of the important issue regarding to the consumer's satisfaction. When we are concentrating to the utility,
Good evening.
we are. You have question. You have question. Okay. When we are going to the utility, we are understanding this consumer satisfaction. In this chapter or in this presentation, we are going to introduce you again the preferences, the utility function, the indifference curve, the marginal rate of substitution, how they maximize consumer preferences, and case demand curves, interior optimum, expenditure minimization, corner points going to be introduced you. Consumer preferences, the issue is very important because, as I said to you, we are dealing with your preferences. We are dealing with your satisfaction. And consumer preferences, very important. It tells us how the consumer will rank. That is, compare the desirability of any two combinations or allotments of goods, assuming these allotments were available to the consumer at no cost. These allotments of goods are referred to as baskets or bundles. These baskets are assumed to be available for consumption at a particular time, place, and under particular physical circumstances. When we are looking to the combinations that we have here, there are three different people and three different combinations. As you look these combinations, the consumer A prefers more clothing than food. Consumer C prefers more food than clothing, and consumer B prefers more food than clothes. Properties of consumer preferences. The first one is completeness. Completeness has means preferences are complete. If the consumer can rank any two baskets of goods, A preferred to B, B preferred to A, or indifferent between A and B. Each basket lies on one indifference curve. If X is at least as good as X1, X is greater than X1, and X1 is at least as good as X, X1 is good or equal to X, implies that X is at least as good as X1. Transitivity. Preferences are transitive. If a consumer who prefers basket A to basket B and basket B to basket C, as also prefers basket A to basket C, indifference curve do not cross. Preferences are transitive. If X is greater than or equal to X1 and X1 is greater than and equal to X2, this implies that X is greater than or equal to X2 either. The properties of the consumers continuing the monotonicity. Preferences are monotonic. If a basket with more at least one good and no less of any good is preferred to the original basket, the more is better. Preferences are strongly monotonic if for any two commodity points X is equal to X1, X2, and X dash is equal to X dash 1 and X dash 2. If X1 is less than or equal to X dash 1 and X2 is less than or equal to X dash 2 and X is not equal to X dash, then X dash is preferred to X. Therefore, the utility function assigns a number to each basket so that more preferred baskets get a higher number than less preferred baskets. Utility is an ordinal concept. The precise magnitude of the number that the function assigns has no significance. As you are seeing, we have here the utility function where utility y, the variable is the y square. And as you see, the function is a curve and it starts from the origin. Okay. Sorry for this. Okay. As you see, is any problem? Is anybody trying to attend or whatever? I don't know what is it. As you see, 0 start from 0 and it goes to A, B, and C. And as you see, A is represents the combination of the total utility of hamburger and weekly consumption of hamburgers. In this direction, we are observing A consumes, let's say, total unit of hamburger 1, and B consumes 2, and C consumes as a let's percentage 2.24. With this utility function, the weekly consumption is going to increase to A, to B, to C. There is a ranking and there is an increasing consumption between A, B, C, and B is less than, sorry, B is less than C and A is lesser than B and C together, or vice versa. And goods, bads, and neutrals. A good is a commodity until which increases utility, gives a more preferred bundle. A bad is a commodity until which decreases utility, gives a less preferred bundle. And neutral is a commodity until which does not change utility, gives an equal preferred bundle. The goods, bads, and neutrals. It is represented on the utility of water. Around X units of little extra water is a neutral. As it is indicated, X is the optimal or top or maximum points. And as you see, until the optimal point of this utility function, the utility is becoming goods, so-called the units of water are goods. And after this optimal maximum, there will be a bad position where the utility is decreasing function of this water is supposed to be reduce its preferences and its utility or satisfaction after this maximum point. And the marginal utility of a good X is the additional unit utility that the consumer gets from consuming a little more of X when consumption of all the other goods in the consumer's basket remains constant. Delta U over delta X is suppose Y held constant is then MUX, which means marginal utility of X is represented with delta U over delta X, whereas Y is held constant and is not considered as not changed. And delta U over delta Y, now then X is held constant, then marginal utility of Y is then represented with delta U over delta Y. And marginal utility is measured by the slope of the utility function. The principle of diminishing marginal utility states that marginal utility falls as the consumers get more of a good. This is diminishing utility. It falls, but it is increasing and it is reducing. The example is given here, a basket of one good, the more the better, as it is represented again here. A is the smallest, and B is going to increase, and C is going to the optimal direction, whereas becomes the maximum, and then it goes downward again. And as I said to you, C is the optimal and maximum approaching point, and is better than B, and B is better than A, and C is better than B and A, and it's like somehow it is preference as it is represented for the between these three consumers or between these three choices. And here another example is given where the hamburgers is represented. A is supposed to be the starting of this consumption, whereas the tangent point of this bundle where the budget constraint or budget line is intersect this utility function, then it goes or the to B, and it goes to the optimal somehow, and then it is going to the C, where the utility is starting to reduce for the point C as it is given in this curve. Here again it is given similar approach is reduced and directed to downward. And here one more example is given, the relationship between marginal utility and total utility. As you are observing, the total utility is given, units given, and marginal utility is estimated delta U over delta X or delta Y, whatever it is. And above is represented with the total utility and the uh, number of units consumed, and the below part it is represented the marginal utility. And as you are observing, at optimal or maximum point of this utility function, the marginal utility intersect the x-axis and it goes downward, which means there is negative utility, there is diminishing marginal utility. And as it is represented here, when you look to this, the marginal utility is given here. The first one is, of course, started with 0. Therefore, 0 minus 10 or 10 minus 0, it gives them 10. And the second one, because every unit is 1, when you going to get the differentiation, 1 to 2, 2 to 3, 3 to 4, it goes to get the first differentiation. And it is, of course, always 1 unit increased unique. Therefore, the total utility is given here 10, 18, 24, 28 somehow. Then it goes, then the differentiation 18 to 10, it gives then the second for the second unit 8. Marginal utility for the third, it gives 24 minus 18 is 6. Then it goes then like this for the fourth, 28 for 28 minus 24, then it gives then 4. And for fifth, 30 minus 28, it gives then 2. The marginal utility, because you're going to divide each time to 1, because marginal utility is delta U over delta X. And as you see, delta X or delta U over delta X is the numbers that we are derivating, 18 minus 10 divided to 1 always, because 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1 always. Therefore, I don't use this. And this will then gives then this curve. Then you got this curve, and you are observing here the total utility on the y-axis and marginal utility on the below curve y-axis, and the number of consumed goods or whatever it is given on the below x-axis. And as you see, this utility function is going to the marginal, let's say, maximum points at where the marginal utility intersect and goes to the negative in this example. The total utility is increasing but decreases by smaller amounts, whilst increases its increasing at decreasing rate, which means, and marginal utility curve is downward sloping. As you see, there are some typewritings mistakes. So yeah, okay. Is downward sloping because of the fact that consumption of successive units gives less satisfaction, as I have mentioned to you, because of this position. As much as you got to consume something like water, the first glass is the best maximum, the second glass a little bit less, but it satisfies, third, 5, 6, and it goes full up, and you don't consume. And if you insist to drink more, this will then cause too much to you, maybe damage your health. Therefore, the utility and the satisfaction is directly related with the amount of the consumption, where you go sat and full up with this, where you feel can get more any from this. And increasing the total utility means diminishing marginal utility maximum. Total utility means 0 maximum utility or marginal utility, sorry. Decreasing the total utility means negative marginal utility when it is intersecting the optimal points as it is indicated, and it is directed to the marginal utility curve and intersect the x-axis. Here is also the total utility curve is given, and the example is very simply illustrated at the above curve. Sorry that I draw it like this very quickly for being able to understand. At the above curve, it is given the utility function as it is mentioned, the y square, and the numbers is already given in the book, therefore we don't have to calculate, but as you are using for estimating the assumption, the marginal utility can be used to estimate by using the marginal utility as it is indicated here, 1 over 2 root square of y as it is represented, because you're gonna calculate it like this, because the root square of the y will be derivated as in this direction, as I have mentioned and given you the instruction for the derivations. And when you are getting this, then you're gonna put the 4. If you are going to get the, let's say, marginal utility for 4, then you will get this 0.25. If it is used the marginal utility, which is represented on the below curve and below graph, then we can use the slope for this. Then when you are going to use the below given curve and graph, then you will get the marginal utility delta u over delta y, which means u2 minus u1 and y2 minus y1 as it is represented here. I put 2.25 as you are seeing to subtract 2 and divide it to 5 minus 4. And this will then gives you again 0.25 because 0.25 will be then same. And or you use the below curve as I mentioned to you for the marginal utility. Similarly, delta u over delta x, then this is then the same again, 0.25 minus 1 and 4.1 minus 4.1 is again 3. 0.75 divided 3 is again giving you the 0.25, which the same answer is obtained from this utility function and from these calculations. This is then the optional, which one you're gonna use for calculating. It is dependent what variable and what parameters and what information or data is given to you for calculating the utility. Is it clear, this simple example? Do you have any question or is not clear? Do you have any question?
It's okay, bro.
Okay. Thank you. Okay, indifference curve. And indifference curve or indifference set is the set of all baskets for which the consumer is indifferent. And indifference map illustrates a set of indifference curve for a given consumer. As it is given here, the U1, U2, U3, U4, or U is equal to 2, U is equal to 4, U is equal to 6, and U is equal to 8. As you see, as much as the utility is increased, it is going away from the origin, and it is always convex to the origin, and it is increasing function of this x and y as much as you are enlarging the utility. As much as the numbers increase, you get better off for this curve. And as it is represented here, the combination is not affecting, but the amount of the utility which is going to affect dependent to the utility function, which is represented on this curve. And as you are observing, on the x-axis is the food and on the y-axis is the clothing. And as you see, as much as the utility amount is increased, this will then enlarge and move away from the origin. And it is increasing the utility regarding to these numbers, which is not given here. And three-dimensionally, it is represented here again. As you see, if you represent it, the utility function, and if you put the y and x in the horizontal dimensions, then you will get this. As you see in the vertical dimension, you have the utility, and the horizontal, you have y and x foods, or so-called the food and clothing. And with this three-dimensional representation, you have the again U2, U3, U2, or the U, which is 2 points or 2 units, and utility for 4 units, and utility for 6, utility for 8, and utility for 10. And the properties of the indifference mark, if you are going to question the preference direction, is becoming important here. As you are seeing, the indifference curve is supposed never intersect each other. Therefore, if it is intersected, there is problem with this indifference curve. And when we are going to the further explanation of the properties, then we are remembering the properties of the indifference curve. The completeness, each basket lies on the indifference curve, as we mentioned, and transitivity, indifference curve do not cross each other, as it is mentioned, and monotonicity, indifference curve have a negative slope and are not thick, because if it is thick, then it will become a problem which is going to be introduced you. As you see, indifference curve lies on a basket, as it is mentioned, and it's at least you are understanding there is a combination of these two, as it is represented here with this purple square. There is y and x combination for this indifference curve, and if it is thick, then this will then create a problem, because then you will then have two different combination and two different level of combination of these two, which is b higher than a, and if it is, the indifference curve is thick, and it's create problem to the consumer. Therefore, the preferences between a and b is not equal, it is different, and b is supposed to be more than a, and therefore, and from this point of view, or from this reason, the indifference curve cannot be thick. And it is negative slope, because as much as you are increasing y, you will get x less. As much as you increasing x combination, you will get lesser y. Therefore, there is a negative slope for the indifference curve because of this negative relationship between x and y. And it is assumed average preferred to extremes, as it is in indifference curve are both toward the origin, which is convex to the origin and not crossing each other, as I mentioned to you. And indifference curve always going or moving away from the origin for becoming more and more regarding to the probably budget or income or disposable income of the consumers or the preferences. There are some options. If the price changes, increase or decrease, is also affecting this indifference curve, and combinations, which we are going to introduce you to the price in consumption curves and income consumption curves. But now on, you just concentrate to these properties. What does the slope mean? Slope means when it is tangent, when the budget line, this budget line, as you see, there's a red line here. If this budget line is, let's say, tangent to this curve, we may say it is the optimal bundle. You may say it is the better combination of x and y. Therefore, where the budget constraint, this line, this red line is here. You see, if this is tangent to this indifference curve, then we have this better off position for this given indifference curve. And the marginal rate of substitution, when we are questioning what's the marginal rate of substitution, is the decrease in good y that the consumer is willing to accept in exchange for a small increase in good x, so that the consumer is just indifferent between consuming the old basket or the new basket. The marginal rate of substitution is the rate of exchange between good x and good y that does not affect the consumer's welfare. The marginal rate of substitution for x and y is then equal to minus delta y over delta x for a constant level of utility. The marginal rate of substitution for x to y is then marginal utility of x will be divided to the marginal unit utility of y. Is supposed to be then the marginal rate of substitution. And as you see, whenever you are substituting this from A to B, you will get lesser y and enlarge x more. Therefore, the utility function is supposed to be decreasing function of y and increasing function of x in this case, or vice versa. Therefore, if the utility function is the function for x to y, is then the function given root square of x multiplied y, then when you are going to calculate these numbers, if you give the numbers here, then you will easily direct and drop the curve easily on this graphic. and you will determine what's the utility is. And as it is indicated here, it is 1. It is estimated 1, or supposed to be estimated 1. The example, the marginal rate of substitution, where the marginal utility of x is delta u over delta x, and marginal utility of y is delta u over delta y. Therefore, when you're gonna put these equations for estimating the marginal rate of substitution, and you will get the answer easily also, and you will find the marginal utility x and marginal utility y for estimating and determining the utility function and utility amount for the given example. And indifference curve usually exhibits diminishing rate of substitution, as I mentioned to you. The more of goods x you have, the less of good y you are willing to give up to get a little more of good x. That's the reason this is diminishing rate of substitution, because as much as you increase a, you will reduce b, or you will reduce b to increase a, or you will, let's say, increase b to reduce a to get more b. Therefore, there is an inverse relationship between this x and y, and any point on this indifference curve, you are okay. But if it is above or below, it's not okay. You have another indifference curve. You have to draw another indifference curve for explaining and understanding the budget constraint and budget line, where it is tangent to these curves. And when we are having our budget line, then we can solve this easily. The indifference curve gets flatter as we move out along the horizontal axis, and stepper as we move up along the vertical axis. Therefore, as much as you go up, this will become vertical. As much as you go down, this will become slope, stepper, and more horizontal, more flatter, sorry. And stepper is more vertical. And here I gave you some examples for the utilities, for the functions with different options. There is here the Cobb-Douglas, where the utility of x to y is a x power of alpha multiplied y power of beta, and it is supposed alpha plus beta is equal to 1. And if it is less than 1, it is supposed it is decreasing. If it is more than 1, it is supposed increasing function. Therefore, perfect substitutes is supposed to be for the given second equation is then ax plus by, and perfect complements the equation is given as minimum in bracket ax and by, and quasi-linear if it is supposed then bx plus by, where you are going to draw some quasi-linear growth for this example. And the Cobb-Douglas is given again here, where alpha beta total is 1. A and alpha and beta is supposed to be a constant, positive constant. And when we give here the example u, x1, x2 is equal to x1 power of 1 over 2, x2, because root square is supposed to be, is 1 over 2, then u is then x1 and x2, x1 and x2 power of 3, then it's represented here with the two different, as you see, indifference curve and the marginal rate of substitution. When you are going to get the numbers here, then you will draw easily these curves, just in case to understand the rate of substitution, which is decreasing for the given examples. You can put the numbers and estimate easily for the given simple examples. And the perfect substitute is given here. As you see, the perfect substitute is a linear equations, as it is given ax plus by is easily estimated. If you give the b0, then you will get, for the y0, you will get the x. And if you give the x0, then you will get the y easily. Then you will calculate the intercept and intersection of x and y axes and draw these lines easily. And here the example is given, u is equal to x plus y. And if you give y0, then x supposed to be 1, 2, 3, 4, 5. Then you draw, as you see, is increasing function of x. And then you draw, you give y, you give x0, then you will then draw y again, 1, 2, 3, 4, 5. As it is a linear equation. Then you draw easily graph and illustrate and represent this example. When it is perfect complements, it's supposed to be, as you are observing here, minimum utility function is minimum of ax and by. Then we're gonna use here then utility function of x1, x2 is x1 and x2, or you can use also x1 plus x2, or you may use minimum x1 and x2 as it is indicated here. The marginal rate of substitution here is marginal utility of x divided to marginal utility of y. And in difference curve with perfect complements, the consumer wants exactly one left shoes for every right shoes, which means either right or left. You're gonna prefer any of these for being able to determine, because as you see, it is an L shape and it gives some correct and concrete preferences between each other. And for example, his utility at basket G with two left shoes and two right shoes is not increased by moving to basket H. This is the numbers which is not illustrated by. You can suppose as 1, 2, 3, 4, because you can put the 1, 2, 3, 4 also instead of H or B or C. Then constraining two left shoes and three right shoes as it is indicated 1, 2, 3 and 1, 2, 3 upside and the vertical on the horizontal axis. You may say as it is written with the numbers also, it can be represented. Therefore, there is L shape and there is a combination of the concrete preferences between these two products. And here there is also quasi-linear. As you see, now we have some curvilinear equation, Vx plus By, where B is a positive constant. As it is mentioned, this is then giving us the slope. And when you get the marginal utility of X is then V is then will be then differentiated with X, and it becomes marginal utility of Y as B, because Y, when you get the differentiation of Y, 1 power of 1 means 1 minus 1 is 0. Therefore, it will become 1, from the differentiations. And when you're going to combine this two with the marginal rate of substitution of X to Y, Y power of, let's say, dash X will be divided to B, because B is a constant coefficient. Then you will get this as a curvilinear curves, as it is indicated here, utility 1, utility 2, utility 3, depending to the budget constraints, which is not estimated. Or you may use the budget constraint. When I'm going to give you the budget constraint, I think you know what is budget constraint. I can show you here easily. The budget constraint is Pxx plus Pyy is equal to I. This is then the budget constraint. As you see, Px is the price of the X, X is the amount of the X product, and Py is the price of the X, and Y is the amount of the Y, and I is the disposable income. This line here, this vertical, so-called the linear line, as you see, these three where intersect these utility curves is determined with this equation. But we don't need to use this because we are still in theoretical definitions and theoretical explanations. If you have a question, you ask me. Then we come to the marginal utility again here. Sorry. Marginal utility of 1 is delta U over delta X1, and marginal utility of 2 is then delta U over delta X2. And then when you are going to concentrate and let's say let the delta U alone, you have to multiply it, divide it to the delta X to each side, or multiplying delta X1 to the right and left for removing delta X1 from the right side to find the delta U for marginal utility 1 and for the marginal utility 2. Then you have to again multiply delta X2 for the both sides. Then you remove again this, and you will get then delta U as delta U marginal utility of 1 multiplied delta X1, and delta U for the second is equal to marginal utility of 2 multiplied with delta X2. Then you will get this as the differentiation of the utilities. Along a particular indifference curve, when we are going to use it is supposed that delta u is 0. Then when you give this 0, then you add these two together. The marginal utility of 1 multiplied with delta x1 plus marginal utility of 2 multiplied with delta x2. This will then gives you the condition delta x2 over delta x1 is equal to marginal utility of 1 divided to marginal utility of 2 is equal to P1 to P2, whereas marginal utility is negatively related. How this comes, I'm going to explain you a little bit quickly. It is given here as suppose the utility, as you know, if the utility function is x1, x2 is then x1 power of 1 over 2, which is the root square, and x2 power of 2, then the marginal utility, if it is quotient, then marginal utility of x over marginal utility of y is equal to delta u over delta x and divided to delta u over delta y. Then from this point of view, if you put this given equation, then you will then get this marginal utility of 2 delta u over delta x2, then x, when you're going to get the power of differentiation of this x1, then you will get 2x1 power of 1 over 2 multiplied with x2, where it is divided, and get this 2 for the x2 also. When we go to the next part, then we question the marginal utilities and marginal rate of substitution. The general equation for an indifference curve is then u is the function of x1, x2 is equal to k, a constant. Total differentiating this identity gives delta u over delta x1 will be then multiplied with delta x1 as it is represented in the former slide, and delta u over delta x2 multiplied with delta x2 is going to be equal to 0, because if you add this to the other side, then you will get the similar, let's say, equation as we have the former slides. The marginal utilities and marginal rate of substitution then is again supposed to be 0, and when we are going to rearrange this and add to the other side of this equation, then we will get then delta u over delta x2, then delta or differentiation of the x2 will be equal to minus delta u over delta x1 is multiplied with the delta x1. Then when we gonna sorry, it stopped. Okay, when we gonna have this rearrangement, then we gonna put this delta x2 to, we divide each side to delta x1, then we have the delta x2 over delta x1, then we add the other side, this delta u over delta x2, and divide this delta u over delta x2. Then when you got this, then you will get upside down. I don't know if you know mathematics, then you will get the upside down of this, and this will then rearrange as like this. Delta u over delta x1, x squared, x2 is equal to x2. Then delta u over delta x2 is equal to x1. Then marginal rate of substitution, then you get delta x2 over delta x1 is then delta u over delta x1 over delta u over delta x2 is equal to minus x2 over x1, and marginal rate of substitution for y, delta y over delta x, then is equal to minus delta u over delta x, minus, of course, these signs, over delta u over delta y, then is equal to minus px over py. Of course, you are questioning where this all comes, and I will explain you a little bit more, don't worry. And then before solving problems, we need to verify these equations. Let me enlarge this a little bit more. I don't know if I'm going to enlarge it, make it a little bit larger. Okay, better. I will explain you this, where this all comes. Yes, please. You have a question?
Trying to understand.
I'm explaining, and you will understand. I will show you how it is coming. This is showing you how this, because I am trying to bring you one equation. We will have some equations for solving problems, and I am explaining how this is coming, where this all comes, and this is the step-by-step explanations. I will come to the conclusion, and you will then understand, I suppose. Don't worry. Look here, at least you are understanding this marginal utility of x is delta u or delta x. You know these things, isn't it? It's normal, isn't it? Because you're going to have the y whole constant, and marginal utility of y is then delta u or delta x when you're going to hold the x constant, isn't it? Is a problem with this? No, I think. Is there any problem? I don't think so. As it is indicated here, marginal utility of y is equal to delta u over delta x1, and marginal utility of 2 is equal to delta u over delta x2 is then upside down this, as I mentioned to you, you multiply it with delta x1 both sides, and you get this delta u marginal utility of 1 multiplied with delta x1 is equal to delta u multiplied, is equal to the marginal utility of 1 multiplied delta x1. And for the second one, marginal utility of 2 is equal to delta u over delta x2. When you're gonna multiply both sides delta x2, you're gonna remove from the right side delta x2 and add to the other side delta x2, and this will then gives you delta u, which means the utility function differentiation. And this will then equal to delta u over marginal utility of 2 multiplied with delta x2, and this will then, of course, similarly written as it is indicated, marginal utility of 2 is the multiplied delta x2. Then when you're gonna divide it both sides to the marginal utility y, then you will get this marginal utility of x over marginal utility of y will then become equal to delta y over delta x, isn't it? And this will then gives you px over py is equal to I over delta y and I over delta x, which means delta x2 over delta x1 is equal to minus marginal utility of 1 is equal to marginal utility of 2 is equal to p1 over p2. And if you are asking me where this all comes, I will show you one more. I have here this continuation of the budget constraint. As I mentioned to you, you know this pxx plus pyy is the budget constraint equation, isn't it? Then you're gonna put here delta x px plus py delta y. You can do it because we want the differentiation of this. No problem with this. Instead of x, you can put the delta x. Because we suppose py is 0. When you put the py 0, you have this px is equal to minus I, which is I is the income or disposable income will be divided to delta x. We get this, isn't it? Then you have here for the px also similarly, when you're going to put the 0 for the px, then you got this 0 here, you remove this, then you have this only px py multiplied dy is equal to I. Then when you're going to get this py is equal to minus I over dy. Then when you put these two together here, px py, you will get this dx dy, isn't it? Did you get it? Or you didn't? So you get these two, and as you are having this, you are reaching to this because you have this, you have this, you have this, and you know that marginal utility of 1 is delta u over delta x, and when you put this together, then this will then remove, and as it is indicated in the former slides, as it is indicated here, then marginal utility of x as it is here, you see, it shows you how it is going to be reached to this equation. This equation you're going to use for solving the problems. Do you have any problem with this explanation, or shall I have to explain one more? Is it clear? You have a problem?
Not really, sir. I'm just trying to understand when we're supposed to be writing the formulas and solving the problems, how are we supposed to write the delta? What does it mean? Like, is it a triangle or English
Delta.
D?
Delta
Yeah,
is the differentiation. Delta means delta when you are going to use this, for example, sorry. When you are going to use, for example, I use D because I have the tastature and tabulator or this laptop. I don't want to use this special Greek delta, isn't it? Because you don't have to show it. But delta X, or as it is indicated, marginal utility here, marginal utility is this one, isn't it? Delta U over delta X. What this has meant, I can show you here. Delta U has meant, I can show you here. Let's put here. The marginal utility has meant U, isn't it? Delta U, U2, sorry, but I don't have any small, minus U1, isn't it? Will be divided to X. Of course, there is here X, let's say, how I'm going to say, because there is here X1, but forget X1. This is X2 minus X1, which means the former last period minus current period, isn't it? X1. You got this marginal utility to calculate. You understand? This is delta. Delta U, this is this one. You didn't get it. I make it separately. Delta U means this one, isn't it?
Mm-hmm.
Delta X means this one, isn't it? Minus. You get it? For finding the differentiation. You got it?
Thank you
Or
very
not?
much.
Okay. And when you divide it this each other, then you will get marginal utility. Okay? Is that clear? What is delta? Is it clear? Or still not clear? If you have a problem, you ask me, because if you don't ask me, how I'm going to help you?
It's clear, it's clear, bro.
It's clear, because I don't know, it's not difficult. Okay, here, then here, as I said to you, I am trying to reach to this equation. This equation we are using for solving the problems. And for this equation, you have this and this from the budget constraints. And this we have from here. We have here this, and this you have here, Pxx plus Pyy. And as I said to you, you put delta, which means differentiation, because we want to get the certain period of time for calculating the utility, isn't it? We are calculating the utility for a certain period of time. Therefore, you are using delta. We are using differentiation. And when we are using differentiation, then delta x multiplied Px, which means the x amount of product, let's say 5, let's say you bought 5 units of x. You may say like this, okay? Look. Can put it here. You got first, let's say you got last week 6 unit of X product, and then last week you got 6 unit, and this week you got, let's say, 10 unit. Then 10 minus 6. This will then give you the differentiation, isn't it? Delta X. You understand? And the price is, let's say, if it is $2, then you multiply it with 2. And if your budget is $10, right here $10, you will find it. Did you get it? This is then the differentiation. And if it is, let's say, $0.5 for X, and this is, let's say, 20 minus 10. This is then the Y product. And you have, let's say, $1.5 for each. You calculate this, and if it is less than or more than, then you may write this is, then you have more budget to consume, or you have something like this. You understand how you are going to do this? Anyway, is it clear?
Yes, it's clear now.
Okay, boy. Okay, then we have from this equation, as I said to you, when you give this 0, this will removed here. And when it is removed, you want to find Px, and you're gonna divide it to the you're gonna divide this here, isn't it? Delta X for finding this. Then you summarize this because it is like this. Is that clear? Because you add the other side. Okay?
Okay, sir.
Okay, then we got this equation, as I said to you, delta x2 over delta x1. You have to use this percentages, or delta x2 over delta x1. marginal utility of 1, marginal utility of 2 is equal to P1 over P2. And when you got this, we gonna use this for solving some problems. Now we have marginal utilities and marginal rate of substitution. An example. Utility x1, x2 is given here. Marginal utility is supposed to be marginal rate of substitution between x2 to x1. Then it is given here, as you see, marginal rate of substitution 1 to 8 is given. 8 over 1 is minus 8. And marginal rate of for the second one, for the red one, is 6, 6. Then this will then gives you minus 6 over 6, which will gives you minus 1, isn't it? Because you're going to divide each other, because marginal rate of substitution here is given x2 over x1, isn't it? And the utility is x2 and x1, isn't it? You're going to multiply it. Therefore, 6 times 6, 36. 1 times 8 is 8. Therefore, we are understanding the red one is better off than x, the gray one, isn't it? And the marginal rate of substitution between these two for the 6 to 6 is minus 1, and for the 1 to 8 is minus 8. Therefore, marginal rate of substitution has meant you have to give up 8 to get 1. You have to give up 6 to get 6, which is equally distributed. Anyway, I think it is the easiest one that you are understanding. And we have one more example here. Then x1, x2, as it is given here, as you see, x1 here, x2 here. Then you have the numbers 1, 2, 3, 4, 5, and you have the here 16, 8, 5.3, 4, and 3.2. Then the marginal rate of substitution, when you are going to put again this equation, is it is given here minus x2 over x1. You're going to get 8, 2.7, 1.3, 0.8. Did you get it? You're going to put this minus x2, 16 over 1 is 16, 16 over 2. When you're going to get this is going to be 8. When you're going to get the other one, x2 over x1, which is 5.3 over 3 is going to be, sorry, 2 is going to be 2.7. Then you're going to get the other one, 4 minus something. Then you get this 1.3, and it's called like this. Then the marginal rate of substitution, as it is indicated here, delta x2 minus delta x1, which in absolute terms is represented, x1 is increasing and x1 is supposed to be, x2 is increasing, as it is indicated here. Therefore, we are going to add this differentiation each other and divide it and get this result. And this is then, as it is indicated here, is represented as a convex curve, because it is so. As much as you are increasing x1, so x1, you will get x2 more. You will get more x1 for reducing x2. Therefore, this is then somehow represented in this direction, which is and which has meant convex preferences, inverse relation, and decreasing amount of increase between x2 to x1. Then marginal rate of substitution, then again delta x2 minus over delta x1 has meant delta u over delta x1 divided to delta u over delta x2 is equal to minus x2 over x1, which is then the delta x2 over delta x1. As I mentioned to you, you're gonna get the 18 minus, 16 minus 8, and you get 2 minus 1, then divide it each other, then you will get 8, and it goes like this, because 8 is less than 16. 8 minus 16 gives you minus 8, and this will then gives you, of course, some negative term, which is negative. And as it is here is increasing, this is decreasing, because when you get the differentiation, you are always getting negative numbers. But as you see, it goes somehow to the 0. It's approaching to the 0, and it will becomes at 0, no substitution probably. Another example, consumer has preferences between two goods that can be represented by the utility function u is equal to x plus y. For this utility function, marginal utility of x is y and marginal utility of y is x. As I mentioned to you, this is the simplest differentiation. Differentiation of x is 1 and differentiation of y is 1 again, isn't it? You know this from the instruction. On a graph, draw the indifference curve associated with the utility level, which is utility 1 is supposed to be 128, then answer the following questions. Does the interference curve intersect each other or either axis? And does the shape of the interference curve indicate that the marginal rate of substitution x to y is diminishing? Or then on the same graph, draw a second interference curve, whereas utility is 200. Show the marginal rate of substitution x to y depends on x and y, and use the information to determine if marginal rate of substitution x to y is diminishing for this utility function. Let's look up this equation and this example. Again, to draw the interference curve, you want 128 for the utility function. U, x, and y, we plot a point where x and y is 118 as 128 as it is represented here. Then we can put some numbers to get these curves, isn't it? This you can give some numbers to draw these curves easily as it is here, x to y. You can give some numbers, then you draw u1, and then for calculating this, you can multiply it any as it is indicated here, and it is given here 128. If it is 128, for example, for point G, if it is xa, then it means then y is 16 for getting 118, isn't it? 128. And point H, similarly, when x is 16, you have to get y 8. And point I, which means x is 32. This means y is 4 because we know that x multiplied y is 128. Is that clear? How are we going to draw the graph? Is it clear?
Yes, sir.
Thank you, boy. And then you can use this for the second one. Let's go to the second part of the equation. For the solution again, can the interference curve u1 intersect either axes? It is asked. Since u1 is positive, x and y must both be positive because it's a positive number, isn't it? Assuming the consumer is buying positive amounts of both goods. If u1 intersected the x-axis, the value of y at that point would be 0. Similarly, if u1 intersected the y-axis, the value of x at that point would be again 0. If either x or y or 0 were 0, the value of u1 would also be 0, not 128. From this point of view, the interference curve u1 cannot intersect either axes. Is it clear? This is the solution. This is the explanation. I think you are understanding clearly, isn't it? And the interference curve indicates that marginal rate of substitution is diminishing because since we give x increases, y decreases, or vice versa, as I shown here, because I told you when you give x 8, it means y 16. When you give x 16, y is going to 8. When you give x 32, it means y 4. Therefore, as much as you are increasing x, y is going to reduce, isn't it? Therefore, from this point of view, we may say there is a marginal rate of substitution from x to y. Is it clear? Therefore, the problem is solved, and we have the next part. Figure also shows the interference curve u2 is 200, which lies up above the u1, isn't it? This is upper part. It is convex, but it is higher than u1, where it is 128. Again, when we are going to use the similar approach, we can put some numbers and calculate the u2 also and draw the graph again. And note that both u1, marginal utility of x, and marginal utility y are positive whenever the consumer has positive amounts of x and y, since marginal rate of substitution x to y and marginal utility of x over marginal utility of y is equal to y over x. As we move along the interference curve, by increasing x to y will decrease, vice versa also can be adopted. Therefore, interference curve will be negatively sloped as it is indicated, because from the shape you are understanding, as much as you increase x, you means you're gonna increase y, or vice versa. As much as you're gonna increase y, you're gonna reduce x. Therefore, there is some inverse relationship between these two variables or two combinations. Therefore, indifference curve will be negatively sloped because of this, and this means that the consumer increases x along an increased curve, y must be decreases. So marginal rate of substitution x to y depends on x and y, and we have diminishing marginal rate of substitution for x to y. Therefore, this is the simplest explanation. Because of this, we say the utility function is the diminishing marginal rate for this given two parameters, or given two, let's say, products. This was the lecture. I gave you some simplest explanation and examples. I can upload if you want some more examples, but there is also some, let's say, exercises that I can upload. You can try as you want. Let me check if we have one more. I think we have one more utility. And after this, then you can get the exercise as an assignment. Is that okay? I think I have the next part. Next lecture, I have one more utility. I will give you interior optimum and some other things, and then I will give you the exercise. If you understand this, for me is okay. Do you have any question, please? You are happy, I think, today. Is that problem? Do you have any question?
No, for me, all is okay, Professor.
Thank you very much. If you don't have any question, or if you have any question, you can contact me via email or WhatsApp, or you will wait the next part of this lecture. Then you will understand. Then I will upload you some exercises with some examples, some sample examples, so with solutions. And I will upload you the exercises as an assignment, and you do it. Is that okay? But this doesn't mean this is your exam. In the exam, there will be the topics that I am doing, and I will give you some summarized information about it if you want. Do you have any question? You don't have, I think, isn't it? I will upload this to the YouTube also. You can watch this video and you understand better, I think. When you are repeating these videos, you can subscribe this video, my YouTube, for the economics lessons. Then you watch these videos and you will understand, because when you are repeating these videos, you playing videos once more or twice more, you will understand better, I suppose, if you have any problem. Okay. Okay, thank you very much for your attendance and you're joining my lecture. If you don't have a question, I'm
So,
stopping you. Yes, please. I'm
no,
waiting.
when will you put the example?
When you will have exam.
When will you example?
Your voice comes broken. When I'm going to upload the assignment, you mean, or example?
Yes, example in assignment.
Sample assignment.